In this video, we would be talking about a theorem in logarithms, which we call the base changing theorem. So what do we mean by the theorem? So let's first define the theorem. What this theorem says is that if you have a log a to the base c, which is divided by log b to the base c, then this value is equivalent to or is equal to log a to the base b. Right? So what does that mean? The base c is not appearing in the right hand side. So it doesn't matter whatever is the base. What you can simply write is the log a, which is the numerator, and you can change the base equal to the value of the denominator, log a to the base b. Let's prove this theorem. How do we prove this? So let's say log a to the base c is x, log b to the base c as y, and log c or log a to the base b is z. So by the definition of log, this implies a is equals to c to the power of x. This implies b is equals to c to the power of y, and this implies a is equals to c to the power of b to the power of z. So with this equation and this equation, what we get is c to the power of x is equals to b to the power of z, right? Because both of them is equal to a. Now let's take this equation and substitute as b. So we'll say c to the power of x, and b is c to the power of y, and then with z. So what does this mean? X is equals to yz, or x by y is equals to z. Right, now substitute the value of x, y, and z. Will give me this equation, which is what we call as a base changing theorem. This theorem would be very helpful in solving many log problems. But let's understand this question, understand this theorem better by solving one simple problem. So let's find the value log 16 to the base 64. Right? So approach 1 is something we take a traditional approach by not taking a base changing theorem. Right? Let's do a simple approach. So we say m is equals to log 16 to the base 64. What does this imply? This implies 64 raised to the power of m is equals to 16, which is 2 raised to the power of 6m is equals to 2 raised to the power of 4, right? And therefore 6m is equals to 4, or m equals to 2 by 3, right? So this is our first approach. Now let's use approach 2. So log 16 to the base 64 is something we can write as log 16 by log 64 through a base changing theorem, and let's choose our base, and in this case I choose a base as 4. So I can write this as log 4 square upon log 4 cube, and when you solve this, take 2 out here, take 3 out here, becomes 2 by 3, right? So this is equivalent, right? So in some sense, if you know the base changing theorem, some of your calculations may become easier. You may not have to deal with very high powers. In this case, it was simple, but you may not have to deal with high power numbers, and you can solve it by taking a right appropriate basis. Cool. Now we have understood this. Let's solve few cases which would be helpful in solving many other problems. So let's solve about 3 to 4 different cases for base changing theorem. So let's say you have to solve log 4 to the base 64. Now this is not as simple as we know that. So we know that if log 64 to the base 4 is 3, because 64 is equals to 4 cube, right? So this is easy. This is not that easy. You will need some calculations to do it, but it's easier. What if I say that this value is equals to 1 by 3? Can we solve this using a base changing theorem? So basically what we are saying is, if you have a value log a to the base b, it is equivalent to 1 by log b to the base a. So let's solve this. So let's take our left hand side and use a base changing theorem, and we say this is equivalent to log a to the log b, and we are free to choose. So this is base changing theorem, so we are free to choose what the base is. So I choose my base as a. So this log a to the base a is basically 1, and the base a. Sometimes just by changing the base, the calculation becomes easier. You can get the value of the calculation much faster. This is case 1 where base changing is useful. Let's see another example or another case. So if you have a more complex problem, just say log a to the base b into log b to the base c into log c to the base d, and you need to find the value of this, where a is equals to 16 and d equals to 4. How would you solve this problem, right? So you don't know the value of b, you don't know the value of c, you only know the value of a and d. So how will you solve this problem? Right, so let's use the base changing theorem. So we said this is equals to log a to the log b, and I'm free to choose any base, so that's fine, into log b by log c, and I say this is the same base as what I would choose here. Let's say that base is x into log c let's say the base is x, log t, and say the base is x. What does this mean? So this and this will get cancelled out. This and this will get cancelled out. So we'll get log a, and then again reapply the log base changing theorem. So we will have log a, and the d will become the base, which then is log 16 to the base 4, which is basically 2. 16 is equals to 4 square. Right, so this equation is then log a to the base. So one faster way of doing this thing is we can directly say if this and this is appearing, we can directly say this and this will get cancelled out. This and this will cancel out, and what will remain is the log a and the base. Cool. This will make you some of these questions easier. Cool. Let's see another case for base changing theorem. Okay, so let's see if you have log m to the power of x by a, and we know that this is equals to x log m to the base a. Right? This is the property we saw. What if I ask you find this instead? How would you find this value? So again, let's use our, so this is more complex than this. So we again use our base changing theorem. So we said this is equals to log m by log a raised to the power of x, which is equals to log m, and I haven't chosen any base because you can use any base when you're using a base changing theorem and it doesn't matter, is equals to x log a, which is basically from this property. Okay? We've used this particular property here, and now again use another base changing theorem. So x 1 by x remains as is, log m, and this a becomes the base for base changing theorem. Right, so this property now is saying 1 by x log m to the base a. Right, so if you have a power in x in a base, it becomes 1 by x of that. So that's another way of solving some of the log problems. Okay, let's take the fourth and the last case. So more than a case, I wanted to prove something. So if you have a raised to the power of log c to the base b, then I claim that this is equivalent to c to the power of log a to the base b, right? So there's an interchanging these two quantities. Can you prove this? Okay, I'll start the proof. So a log c to the base b. I can write this equation as a log c to the base b into log a to the base b into log a to the base c into log c to the base a. Right? Because this is basically 1. We can cut these two values, we can cut these values, but this value is equivalent to 1. Right? So now let's rearrange this value. Let's take this value and bring it here, and rearrange this value log c to the base b into log a to the base c. So what does this mean? So this and this will get cancelled out. So this will nothing but a log c to the base a into log of a to the base b. Now, what if we can say that this value is equivalent to c? Then we would prove this value. Right, so we now only want to prove that this value is equivalent to c. So let's say a log c to the base a, which is this value, is x. So let's take a log on both sides. So we can say log a, the base a, is equals to log x to the base a. Now this is the power within the log, so I can take it out as a multiplier. So I can say log c to the base a is equal to into log a to the base a is equals to log x to the base a. This is essentially 1. So log c to the base a is equals to log to the base a. And what does this implies? C is equals to x. It's basically this value. So we can substitute this value as c. This is the last and the fourth important case to help you understand some ways how can you use base changing theorems in log. We will do more questions both for properties of log and base changing theorem in some of the videos to come. In the next video, we will talk about some common values, what log of these bases which are used in logs. We will talk more about that. Thanks.